Comment 1501 is basically telling you how to do a domain question. It's telling you to pick from a toolkit. Now, there are a number of comments like this where I tell you to pick from a toolkit. So comment 927 does the same thing, for example, for graphing. There's also a very large toolkit of some 7 items by the end of year 12 for factorization. That toolkit is a little briefer for GCSE. But for questions like, for comments like this, where you're told to pick from a toolkit, if you're getting this comment a lot, then you need to almost learn off by heart a little summary page, like a little summary poster with spider diagrams or other schemes to help you remember what this list is, so that you can just comb down and pick from it. Now, the toolkit for domain is this. First of all, what messes the algebra up? Okay, so for example, y equals 1 over the square root of x. That algebra is fine most of the time, but a square root cannot handle 0. So therefore we know automatically that anything less than 0 is not in the domain, because this square root symbol can't handle it. Also, you can't divide by 0, so in fact x equals 0 is not in the domain. So the domain, which is called the natural domain when you do it by this method, is that. It's x strictly greater than 0. So that's the first technique, what messes the algebra up. Number 2 is restrictions in brackets. So if I have y equals 1 over root x, but off to the side it says that x is greater than 1, then that means that after having checked what makes the algebra work, you now need to restrict it further to just these. So for example, well, in this case that I have here, the natural domain of this is just numbers that are positive, but then this little restriction comes along and tells you that we're only, for this question, looking at numbers that are bigger than 1 as well. So basically the domain is whatever makes x greater than 0 and whatever makes x greater than 1, which means the domain is just x greater than 1. So that's your second method. Now, it's not always with these little inequality symbols that we do it. Sometimes we use these little symbols. That means that x is just a positive whole number. The most general one is this. That just means x is a real number. And you, unless you do further maths, can just interpret that as meaning regular. It just means x is just a regular number, whether it's decimal, fraction, or a negative number. You know, all the numbers that year 7s know about. Question number, so technique number 3 is to draw a graph, or to use a graph. So here's a graph. When I was doing the domain of that, I would just scan the x-axis, asking can I see a graph above or below or on me. So if I'm there, there's no graph above me, there's no graph below me, and there's no graph on me. Same there, so it's no, 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 yes, because there's graph dead on me there, so that's a yes, 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 yes. These are little ticks, by the way, because there's graph above me, that's why I'm ticking yes, 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 yes. Then here, because there's a hole in the graph, the answer is suddenly no, and then it's yes, yes, yes again. And that, by the way, is why I'm always telling people to put arrows on the end of their graph, because if that arrow hadn't been there, if it was this, I would now resume crossing again. But anyway, that was a arrow, so that means it's ticked forever. So let's say the x coordinate was 5, so that means the domain is x between 0 and 5, including 0 but not including 5. and also the section greater than 5, and fancy pants way of joining those two areas together is with this symbol which stands for union. So that's the third method, is to draw a graph and scan the x-axis or the y-axis. And the fourth method is a funky little trick, which is that the domain of the inverse is the range of the original, and vice versa. This is supposed to be a quick little technique. If in part C of some question you've been asked the range of the inverse and you've written y is greater than -3, greater than or equal to -3, and in part C you get asked for the domain of f, just literally copy this out. Every last character, save for 1, you must always express domains with x's and y's with and ranges with y's. So that is literally a little 1-mark question. The idea is you just literally pinch the range of the inverse, because as I say here, the domain of the inverse is the range of the original and vice versa.